Dear guys, welcome to my channel. On my last lecture, I discussed about JT coefficient for various gases, and there we see that JT coefficient for perfect gas vanishes. That means for perfect gas there is neither heating nor cooling, and we also find the value of JT coefficient in case of a van der Waal gas, and there arises three different cases, that is heating, cooling and inversion. Okay, so we have already introduced the concept of inversion temperature. Now in today's lecture I shall going to discuss the existence of two inversion temperatures, that is there exist two inversion temperatures. Why? Okay, so existence of two inversion temperatures. Okay, now here we took the real gas equation. Okay, that is for 1 mole real gas we can easily write the van der Waal equation of state this for 1 mole. Okay, now simply multiplying we get this. Okay, now differentiating this expression with respect to t, keeping p constant, p del v del t pressure constant, this term is constant, so 0 minus a by v square del v del t pressure constant plus 2ab by v cube del v del t pressure constant, this must be r. Okay, so this is simply del v del t pressure constant p minus a by v square plus 2ab by v cube, this is simply r. Now what we get, from which we get del v del t pressure constant, this is simply r by p minus a by v square plus 2ab by v cube. Okay, del v del t pressure constant we get r by p minus a by v square plus 2ab by v cube. Now substitute this value in JT coefficient expression. What we get? If we substitute this value in JT coefficient expression, then what we get? Mu, this is 1 by Cp T into del V del T pressure constant, that means RT by P minus A by V square plus 2AB by V cube minus V. Okay, we substitute this value in JT coefficient expression. Now we have to put P plus A by V square into V minus V instead of RT. So if we put it and simplify, we get this. This is simply P minus A by V square plus 2AB by V cube minus V. So this is simply 1 by Cp. This is simply P minus A by V square plus 2AB by V cube. So if we simplify it, we get PV minus PB plus A by V minus AB by V square minus PV plus A by V minus 2AB by V square. Okay, so PV cancels. Okay, so what we get? 1 by Cp, this is minus PV plus 2A by V minus 3AB by V square. by p minus a by v square plus 2ab by v. Okay, so at first, by using real gas equation, we find the value of del V del T pressure constant and then substitute that value in JT coefficient expression. We will get this type of form. Now what will happen in case of inversion? In case of inversion, mu is 0. We discuss it later. We discuss it earlier. So if mu is 0, then this term that is in the numerator term will be 0. Okay. So the numerator term is 0. So for inversion, mu is 0. That means this term is 0. So minus pb plus 2a by v minus 3ab by v square, this term is 0. Okay, so from which we give pi because p inversion pressure, we get this 2a by bvi minus 3a by vi square, that is pi vi denotes the inversion pressure and the inversion volume. So a close look on this equation, if you look closely into this equation, then this is a quadratic equation, second order equation. For each p there are two values of v. Okay, so equation 1 is quadratic in nature. So obviously you will find for each p there are two values of v, and these two values of v determine two inversion temperatures. Okay, so for each p there are two values of v. Okay, for each p there are two values of v, and these two value of v determines two inversion temperatures. Okay, so obviously these two values of v determine the two inversion temperatures. Now if we substitute this value, okay, in van der Waals equation, then we will get the expression of inversion temperature. Okay, so if we substitute the value of inversion pressure in van der Waals equation, we will get the inversion temperature. So what is this? P plus a by v square. That means this plus a by v square means 2a by bvi minus 2a by vi square into vi minus b. This is equals to RTI. Okay, we substitute the value of inversion pressure in van der Waals equation. Okay, so what happens if we take 2a by bvi common? If we take 2a by bvi common, 1 minus b by vi, and this is vi minus b, this is equals to RTI. Okay, fine. Now what we get? 2a by bvi into vi minus b whole square, and there is also a vi term in the denominator. This equals to RTI. Okay, Now what will be my Ti from this? My Ti will be 2a by Br into 1 minus B by Vi whole square. Okay. Ti, this is equal to 2a by Br into 1 minus B by Vi whole square. Okay, so this is the expression of inversion temperature. Okay, so this is the expression of inversion temperature. This is the expression of inversion temperature. Okay, 2a by Br into 1 minus B by Vi whole square. Now if we plot a curve between P and V, that is from the quadratic equation, then if we plot a curve, then the curve looks like this. This is simply P and this is simply V. The curve looks like this. Okay. No, sorry. The curve looks like this. There is a intercept. Okay. So clearly this is V1, this Vi is 3 by 2 and this Vi is infinite. So for these two values of Vi you will get to immersion temperature. So the curve looks like this. Okay. Here this intercept is 3b by 2 and this is infinite. So if you draw a PV curve, in this case pressure volume curve, then the curve looks like this. Okay. So by using these two values of V, we will determine to immersion temperature. So let's check. When say we take V1 3 by 2, then what will be the value of immersion temperature? Say Ti1, that is 2a upon Br 1 minus B by Vi, that means 2/3 whole square. This is simply 1/3, 9, that means 2a upon 9 Br. 2a by 9 Br. Okay, so Ti1 this is equals to 2a by 9 Br. And if you take Vi, this is equals to infinite, then what will be my Ti2? My Ti2 will be, if Vi is infinite, then B by Vi is 0, so that means 2a by Br. Okay. Ti1, this is Ti2. Okay, so which one is greater, 2a by Br or 2a by 9 Br? This term is greater. So we see that the second inversion temperature, that is Ti2, this is greater than the first inversion temperature Ti1. Okay. So thus we see that there exist two inversion temperatures and the second inversion temperature is greater than the first inversion temperature. Okay. Now we will do a simple problem based on JT coefficient. Okay. Now we have to show that delta T is 0 for ideal gas. For ideal gas, delta T will be 0. How? Okay. Now write down the Joule-Thomson coefficient expression, that is dT/dP. This is equals to 1 by Cp T del V del T, pressure constant, minus V. Okay, fine. So if we imagine the temperature difference or tell the temperature difference delta T, then the corresponding pressure difference will be del P. So from which we can easily write del T, this equals to this 1 upon C T del V del T pressure constant minus V into delta P. Okay, fine. Now for ideal gas, we know for n mole ideal gas we can write PV, this equals to nRT. PV equal to nRT for n mole gas. So differentiating this term with respect to T, keeping P constant. So P del V del T pressure constant, this is equals to nR. Okay, P into del V del T pressure constant, this is equals to nR. Okay, so what is del V del T pressure constant? We all know alpha is volume expansivity term, that is increase in volume 1 by V del V del T pressure constant. Okay, alpha is the volume expansivity, increase in volume per unit rise in temperature, from which del V del T we can write V alpha. So PV alpha, this equals to nR. Okay, okay. So what, again we put PV equals to nRT, PV equal to nRT into alpha, this is equal to nR. So from which we can get alpha T, this is equal to 1. Fine. Okay, so PV equal to nRT, differentiating this expression with respect to T, keeping P constant, we get this. So we put del V del T pressure constant as alpha V. So P alpha V equal to nR. Again PV equal to nRT. So nRT alpha equal to nR. That means alpha T is 1. Now just look into this equation. This equation can be written in this form of alpha T, because delta T, this is 1 upon Cp. Del V del T pressure constant means alpha V. That means T alpha V minus V into del P. So if you take V common, so V by Cp, this is simply alpha T minus 1 into del P, and put alpha T 1, that means del T is 0. Okay, so this is simple interesting problem. Okay, so this equation can be written in terms of alpha, because we put del V del T pressure constant as alpha V. So take V common, so V by Cp into alpha T minus 1 del P, and already we have proved that alpha T equal to 1 for ideal gas. So for ideal gas delta T is 0. Okay, so in today's lecture I shall discuss about the existence of two inversion temperatures, and I do one numerical problem. Okay, so in our next class I shall discuss about the differences between adiabatic process and JT process. Okay, so dear guys, kindly subscribe my channel to get latest videos on physics. Okay, thank you.